What did I say the quiz is going to be on? Let me go look at my videos. So, but I hope they might be helpful for anybody. All right, so last time we got up to this point. I'm going to redo these because I think somebody was asking me about these. We didn't really do these together. We just did these two, right? Okay. And I really, so again, can somebody tell me, what's the basic operation that OR implies? Addition. OR is a nice pound, sir. They add and add more people. More people can get in, right? So if I said, I want everybody who's wearing glasses to come with me, that's I think 3 people in here, right? Or if you have a hat on, now that's 4 people, right? Or you could have a shirt that's got, what is that?
Lemons.
What is it?
Lemons.
Lemons. You have a shirt with lemons on it. Then you can come with me and I'll give you a cupcake, right? I mean, guess kind of follows. So or increases the number of things that match, so that adds to things. And is basically, or is basically add, and is basically multiply. That decreases the number of things. And our brain doesn't think like that. Our brain says multiply makes things big. Not when it's between 0 and 1. It makes things smaller, yes? Is that okay? So, and means multiply. So somebody remind me, why is this 2 out of 21 here?
Because you're looking for 2 people inside there that could be.
Why am I looking for 2 people? What do you mean? Yeah, I'm looking for independent people. Right? That sounds weird, but I'm looking for people who identify as independent. And how many of them are there? 2. There you go. So there's a 2 out of 21 chance that the first person I pick is an independent. And times, I put them back in. And that's why the next probability doesn't change. The probability of the Republican is still 12 out of 21, like we got earlier. Okay. Now somebody help me out. Remind me, this is the same question, correct? Here and here, they're the same questions? But it's 2 different situations. What was different in the second situation? Say again?
We lost the marble.
I love it. That's right. We lost the marble. Kick-ass. I like that because politicians, a lot of them lost marbles. So yeah, in this case, we took a person out of the haunted house and we actually let them leave, right? Thank you, get out. So this person was an independent. We chose them and then we said, get out of here. So now there's still 12 Republicans, but there's also now 1 less person in the house. Does that make sense? So if I do something without replacement, every time I do something, all the probabilities change because the denominator at least changes. So let me get a clean sheet of paper. Let's do this. I want to select 2 Democrats. Do you see the word and there? No, but if I say it a different way, I want the first person to be a Democrat and the second person to be a Democrat. So that's kind of like a hidden and. So that's, I want 2 people. I want the first one to be a Democrat and the second one to be a Democrat. This is with replacement. So it's probably the first person is a Democrat. 7 out of 21. I put them back in the house. So what's probably the next person's a Democrat? 7 out of 21. And if you do that, you'll get
0.1.
wow. Yep. By the way, quick side note. Isn't 7 out of 21 1/3?
Yes.
And this is 1/3, and 1/3 times 1/3 is 1/9, correct? You with me? And also, real quick, sorry. Math guy, math stuff. You guys know what 1/3 is as a decimal. Most people know 1/3 is a decimal, right? 0.3333. Isn't 1/3 the same thing as 3/9? So then 1/9 would be this divided by 3, correct? And what's this divided by 3? Well. Okay.
nifty shit. Okay, sorry. Side note. All right. Is everybody good with this? I really want you to get to the point where you realize if I give you this kind of problem, there's 11 blue marbles, and and you're like, oh, thank God, holy shit. All I got to do now is, if it's with replacement, I just multiply the probabilities as I go through. I want a white marble and then a blue marble. Okay, just multiply those probabilities. If I do it without replacement, I just lose a marble each time. So here, what's going to happen here now? I want to select 2 Democrats, but I'm not putting them back in. So when I pick the first one, I haven't done shit yet. So what's probably the first person is a Democrat? 7 out of 21. Now I let them leave. How many people are in the House now? How many Democrats are in the House now? 6. So what's probably the next one's a Democrat? 6 out of 20. Why did the top number change this time? Because the thing I picked first was what I wanted second. So of course I lost one of those things. Okay, I really want this to make sense, obviously. Okay, all right, I like it. And then whatever the hell that is. I don't know. Is it 10%? 0.1?
Yep.
All right, sweet. By the way, if you need to borrow a calculator, just come on up anytime. Do it real quick. Let's look at number 3. Number 3 is really important because there is a homework problem I'm going to look at with you in a minute because it involves a slightly different skill that we talked about. And kind of is what's happening here. Read through number 3. This is a true story, by the way. I've provided the link. We'll also talk about how it's not quite saying what it sounds like it's saying. What is your reaction on reading that?
A little disappointing.
Yeah, hopefully nobody's out there like, yeah, of course, what the hell?
I mean, everything.
7% of people got this right. That's what we're talking about. But real quick word about that. The way they worded the survey was a little misleading. So this doesn't really accurately portray anything. Unfortunately, I think it is more than 0%, but it's probably not quite 7%. But let's just go with this. Okay, just want to put that out there. That's why this says with a grain of salt. So if you go to that link, you'll see. Now here's the new part of number 3. We're taking 4 people, right? So it's a little bit more. So it's just like number 2, except now instead of 2 people, I'm taking 4 people. But there's a bigger, all right, I really want this to make sense. Somebody up here, are these very different numbers? You guys see this? Not that different. But in the grand scheme of things, a 1% change is actually pretty huge. I want you to understand, especially when the thing I'm talking about has a lot of, like if we're talking about all Americans. Does anyone know how many Americans there currently are? The number of people living in America, let me say it like that.
360 million or something?
Yeah, it's about, I think it's 340, 350. I don't think we've hit 360 yet, unless, I don't know, people have been getting. But 340, 350. Anybody know what 1% of that is?
That's 350,000.
Yeah, so if you take 350 million and you just cross out the last 2 zeros, 350,000. So that's just a 1. If the number of people who died from COVID went up from 1%, that's 350,000 people. Do you understand? Okay. So 1% is actually not that small of a difference. But in this case, it's because the sample, is the sample size really big on number 2? No. So like a 1-person difference is huge percent-wise for number 2. Now let me ask you this. On number 3, how many people total is it referencing?
7% of the United States.
It's referencing everybody in the U.S., yes?
Which is
350 million.
336 million currently.
Is it 336? Okay, I thought we hit 340, but of course we lost some people, so I mean, that'll help.
334.
330
That's
something.
336.
Okay, gotcha. All right, 330 something. We'll leave it at that. If I take 1 American out and I put them on a boat, Has the number of Americans changed by much relative to how many there were? Okay, I really want this to make sense. When I have a very small sample, I must keep track of how things are changing, because if I only have 21 people and I lose one person, that's a huge change. If I have 330 something million people and one person leaves, I'm not going to give you my money. We're going to be like, I don't give a shit, right? That's why I love people. I'm going to boycott you. Okay, go ahead. We got plenty of other people paying this shit. We don't care. So one person leaving does not change things at all. Somebody help me out. What is, let me put it up here so it's on the video. What is the point, Jeff? Oh, what is,
I feel like half of 7 million leaving from would be a big number.
what is 100 divided by 350 million? Somebody help me out. Actually, let's do this. Let's make it 10,000. Yeah. 10,000 divided by 350 million.
Like 0.00029.
All right. So what you guys are getting? I see a lot of people doing it. You guys got that? Go further. Does it say any more?
No, that's
That's it? Okay. Now, what if I took one person? Let's say these are the people that, think that chocolate milk, whatever. What if I take one of them and put them on a boat and set them adrift? Now, how many people? Now there's going to be 9,999 out of 349,999,999. Is everybody cool with that? Just like 7 out of 21 became 6 out of 20 for that the Democrat problem. If I take one of these people, what is that when you divide it?
I think mine's rounding because it's the same thing.
Yeah. It's the same stupid thing. All of this means, when my population is huge, look at what I can do. Look what I can do. I got 4 people, right? I'm going to choose 4 people, yes? I want the first one to think that chocolate milk comes from brown cows. What's the probability the first one thinks that?
1 in 4.
Say again, sorry?
1 in 4.
No. Say again?
You generate from the population 7%.
Totally. I know what the probability is that somebody thinks that an American thinks that chocolate milk comes from brown cows is 7%. What's probably that an American doesn't think that? 93%. So the first one thinks that, and the other 3 don't. So what am I going to put in the other 3? 0.93. I know this is all weird. You don't have to think this way very often, but I want to show you one of the most common mistakes I used to always get is somebody would do this problem and they would say, all right, 7 out of 100 for the first guy, right? It makes 7%, right? Times 93 out of 99 times 92 out of 98 times 91 out of 97. Do you see what they're doing? Just like the Democrat problem. But how many Americans are they saying there are? They're saying there's 100 Americans. Right? Are there 100? Talk about the space we would have. But are there 100 Americans in the United States? No, there's a little bit more. All right. So the summary of this is, if I have a really large population, I don't have to do this shit. I can just take the percentages and multiply them, because how much will it change? Barely at all. I mean, like in the 18th decimal place or something silly. Maybe. So why does this make sense? The first one thinks that, and the last 3 don't. What's another way I could write this mathematically? Isn't this 0.07 times 0.93 to the 3rd power? And this is understood first power here. Look at this. 1 of these, 3 of those. Bam. A math equation actually you can just read. I got 1 person like this and 3 people like that. Bam. Now somebody help me out. What is that? 7.49? No, 0.049?
I got 0.056.
Okay, that's close.
305.
Is that what you guys got? Everybody with me? Okay. Now, real quick, we'll talk about part B. Part B is a little bit interesting. But let me do a part A, subsection 2. What if I wanted the first one doesn't think that way, and the last 3 do? How would I set that up?
You just kind of reverse it, so when I agree.
Yeah, the first one doesn't, and then the last 3 do. And then you throw in the old calculator and get whatever the hell you get. Right? So, I mean, you can control each spot. I want this person to do this. Okay, look at the probability for that, put that there. And then these people to do this. Okay, put that probability there. Anybody not see where 93 came from? 0.93? No? Okay.
I was gonna say, I got 0.00031889.
Yeah, that's what I got. No. Very small, which makes sense. It's really unlikely to get that many people when there's only a 7% chance to get one of them. Okay. All right, maybe. Now, look at part B. That doesn't sound like that big of a deal at first. But how many ways could you have at least one person think something? You have 4 people and you want at least one of them.
You could have one,
I could have one person think that way?
you could have 4 different ways of that coming true.
No. Nope. More than that, but I see what you're saying. All right, I want at least, what does at least one mean? It could be 1, or 2, or 3, or 4. If it's 1, it could either be the first guy, or the second guy, or the third guy, or the fourth guy. If it's 2, it could be the first 2, or the last 2, or the middle 2, or the first one and the last one, or the first one. If it's 3,
Oh, 16.
that's a lot of work. Oh, interesting. Yeah. Okay, you're thinking the right way now. But we're not going to even do it that way. We're going to be smart. We're going to do this freaking quicker. Does anyone want to do all that? I really want you to understand. The answer to a probability question is the addition of all the things that match what it's looking for. What does at least 1 mean? It could be 1. Okay, that situation, first one, or second one, or third one, or fourth one. I would set up the situations and add those numbers. I'm not done. Because it could be 2. Oh shit. There's a lot of work, correct? One really kick-ass thing about probabilities. If the probability is going to rain today is 5%, what's probably not going to rain? Holy shit. 1 minus that, correct? If I calculate the opposite probability and do 1 minus that, I get the actual answer. What is the opposite of at least 1?
99. 3.
Yes. If I said at least one person in here loves statistics, not including me, how could you show that I'm wrong? What's the only way you could show that I'm wrong?
You have to survey everyone and then make sure no one likes it.
None like it, yes? That's the only way you can show I'm wrong, is to show that nobody loves statistics. Are you with me? Well, it's here goes down. I really want this to make sense. Any damn time I ask you a probability question and the opposite situation is easier to do, shit, yeah, I'm going to do that, and then I'll do 1 minus that. 1 minus, if I calculate the opposite of what the question wants, and then I do 1 minus that, I've answered the question. Because how do opposite probabilities relate? One is 1 minus the other one. So the opposite of this, so if I do 1 minus the probability of 0, nobody wants it. Now how do I get the probability of 0? I want nobody to think that way. That means they all, what? I want nobody to think chocolate milks come from the brown cows. Do any of them think that way? Do any of them think that then? If I want nobody to think that way.
93.
What's probably the first one does not think that? 93. In fact, they're all going to be. So several steps here. The question would take way too much work to calculate directly. So what I'm going to do, I'm going to be freaking clever. I'm going to calculate the opposite of what it wants and then do 1 minus that. The opposite of at least 1 is none. If I want none of them to think that way, then I'm going to put the opposite probability for each of them. There's a 93% chance each one of them does not think that way. Help me out. What is this? 9876, so 0.6721.
0.74.
Damn it.
8052.
8052, so 81.
Yep.
So then the actual answer is going to be 1 minus that. I really don't know. I almost don't care. I do a lot of side notes, but this is going to happen often enough. Does anyone know a trick to do this really fast? I know you can do it in your calculator, but we're humans. Let's be better. Anybody know how to do that really fast? Sometimes people have been shown this. What makes this 9? 2. What makes this 9?
9.
What makes this 9?
1.
What makes this 10?
9.
There. Check me. Do it, check me. All right. This is kind of related to the whole carry the one shit. Or, borrow and do the one and all that kind of stuff. That's a neat little trick. How to do 1 minus a decimal. Make everything 9 until you do the last one, make it 10. Okay, maybe. Or just put it in your calculator. I'm sorry, guys, but, yes.
I'm so confused why it's 1 minus 0.741
Oh.
instead of 0.741.
This is the answer if the question was, what is the probability that none of them? But the question is, what's the probability that at least one of them, right? If the probability is going to rain today is 5% chance, what's the probability it's not going to rain?
Wait, is that what?
If the probability it's going to rain today is a 5% chance, what's the probability it's not going to rain today?
95?
95. 1 minus 0.05. So how do opposite probabilities interact? One is 1 minus the other one, right? If there's a 30% chance that I'm going to get hit by a golf ball, what's probably not going to get hit by a golf ball? 70%, right? 1 minus that. So the opposite of at least 1 is none. So if I calculate the probability of none and do 1 minus that, I will answer the question.
Can you write it out so I can
Yeah, in fact, I'm glad you're saying that. Let me do this.
I have a question about that problem.
Yeah.
So if it was like the probability that at least 2 of them think that, it'd be 2 minus probability 0.
No. It's 1 because that's the most the probability can be. So watch this. Real quick. This is important. How many people could think that chocolate milk comes from brown cows if I have 4 people? All 4, or 3, or 2, or 0. Okay.
Or -1.
That would be neat. That's getting a little tricky. The guy that's in the next universe over, he just told me. Yeah. I don't know whatever. Each of these has a certain probability, correct? In fact, don't we know that didn't we just calculate the probability 0 is 0.7481? Are you guys with me?
Yeah.
Whatever the shit these other things are, what do they all have to add up to be?
0.1.
Don't they all have to add up to be 1? Yes? Are you guys with me? I really want you with me.
Oh, yeah.
If all of these things have to add up to be 1, what is 1 minus this? The frickin' rest of it, yes? If they all add up to be 1. So probability of 0 plus probability of 1 plus probability of 2. I don't know if you can see this. Yeah. Plus probability of 3 plus probability of 4 equals 1. So what's the probability of at least 1? 1 minus the probability of 0. Thank you, algebra. You saved your ass again.
don't get rid of that yet.
No problem. This is going to happen often enough in here that I really want to make a big deal of it. Now, your question.
This is at least 2 of them. Right.
If I said at least 2, it would be 1 minus the other thing. So it's always 1 minus the shit that the question left out.
Oh, and probability of 1 is 0.07931993, right?
Probably 1 is, okay, if you count. Did we calculate that?
I don't know if you calculated that, but at least setting out that might be 0.07 times 0.93 cubed.
No. Okay, real quick. All right.
Or
I'm sorry, did I take that away too early? You got it? I did? All right.
0.07 squared
I'm a
times 0.93.
jackass. Okay.
If-
Say again?
So if the question were, at least two of them think that chocolate milk is black cows, be 0.07 squared times 0.93 squared, right, and that'd be probability of 2.
No, stop. I'll show you why it's not quite right. Okay. Real quick. Okay. Part 3A is very specific. If I said the probability of one person thinking that way, why does 3A not answer that question? It doesn't. Question 3A does not answer the question of what's the probability that exactly one person thinks that way. This one asks what's probably the first person thinks that way. So is that every way to have one person think that way? What's another way to, if I have 4 people lined up,
You have 4 different ways.
it could be the first person or,
Same thing.
see, or I'm going to add this shit. So I'm going to do the setup for first person, then I'll do the setup for the second person, seven for the fourth person, and then I'll add all that shit together. You with me? Because if I said, let's probably pick an ace or a 2 from a deck of cards, and you tell me 4 out of 52 because there's 4 aces, I'm like, why didn't you add in the 2s? There's a whole other way to do what I asked you to do. So you're going to add all the stuff that you could do. But don't freak out. In chapter 4, one of the last things in chapter 4 is going to talk about a quick shortcut to do kind of like what you're saying. What is there a shortcut to do? Because if I wanted to do 2 people, exactly 2 people, I really want you to understand how that would suck. It could be the first 2, or the last 2, or the middle 2, or the first one and the third one, and this one. I mean, can you imagine if I have 80 people and I want 7 of them? Could be the first 7, or the last 7, or the first 2 and the last 5, or the first 1 and the middle 3 and the last. Holy shit! Section 4.3, we'll learn a shortcut for that. Thank the gods. Are we going to have to do it now? Oh, hell no. Hell no. Yes.
Why does that matter if we're just multiplying it anyway?
Why does what matter?
Like, the order in which it is?
I love it. Okay. Let's do this. I love this. Stay with me. This is awesome. I 100% agree with you. But I want to show you how I think you're not quite seeing it the right way. So if I want the probability, let's see. This is all about thinking the chocolate milk. So let me do this. Let me call B somebody who thinks, no, let's not call it B. Let's call it C. C is the event that somebody thinks that way, right? Thinks that chocolate milk comes from brown cows. You with me? All right, cool. And let's say, let me introduce, well, it's okay, Joe. Let's call D means they don't think that way. You with me? Is that all right? So what's the probability of C?
Points, or 7%.
Oh, so 11. Is everybody with me? Okay. And what's probably somebody who doesn't think that way? 0.93. Kick ass. Okay. So if I ask you, what's the probability exactly 1 if we pick 4 people? Watch this. The first person could think that way. What do I call it? C. And the last 3 don't, correct? Or the second person could think that way and the other 3 don't. Or, you see how it's a nice quick way to capture all the different ways without using too many words? Does everybody agree with me there's 4 ways? Mathematically, does the math give a shit in each situation? Isn't each situation the same number?
Yeah.
Because wouldn't this be, let me see if you guys cool it. Isn't this C, D to the 4th? Jeff. 3rd? And what's this? C, D to the 3rd? So don't I have 4 C, D to the 3rd? So that I would just take my answer to part A, multiply by 4.
So, it doesn't matter in this scenario.
Yes, exactly.
Okay.
Because they're all mathematically the same.
What would have to happen for it to matter?
We'll get to there. I don't want to do, I've already gone way further than we need to right now. I'm going to actually bring this back when we get to chapter 4, because this kind of leads into the shortcut. And we're almost basically there, but Let's not go too far. I appreciate the question, though. I just don't want to go further than we need to right now. Okay. What's the takeaway from this? This is the most commonly used scenario. If I wanted to check my, if I'm making a batch of medicine, and we're gonna check like a sample to see if anything has contamination. You with me? Would it be bad if there was contamination in some medicine?
Yeah.
Yes. So if I take a sample, I'm gonna throw the entire batch out if I find at least one of the vials of samples I took has contamination. Would you agree that's a good thing to do?
Yes.
Because that probably means other things are gonna have it from that batch. I need to like restart over, something went wrong. You guys with me? So often, we wanna calculate if the contamination probability is 0.007, what will the probability of at least one being contaminated be? And that could tell me, is my quality assurance actually catching enough? Should I take a larger sample? And again, this is going a little further than we have to, but that's why we focused on at least one. So what can you do right now? If you see the question, what's the probability at least one thing does this? You calculate the probability, none of them. Because how many ways can you have no, but none of them? One way. How much work did we have to do this? One thing, right? There's the only way to have none of them think that way. And then 1 minus that. So the probability of at least one is 1 minus the probability of none. Okay, I like it. So it's a nice shortcut for at least one. And why do we focus on that? Because it's one of the most often used probability things to look at is at least one.
That makes sense.
Now part C, you're going to see problems in the homework that sound like part C. Read through part C real quick. By the way, I feel really silly about this, but it's relatively recent in my life that I had Brussels sprouts made the right way. When I grew up, my mom would boil them, which is the absolute worst way. But if you've never had like roasted, now I'm making myself, you've ever had roasted Brussels sprouts with some olive oil and other stuff in there? Oh, yes.
My work does that. It's like, I work at, you know Lazy Dog, Richmond Valley?
What is it?
Lazy Dog?
Lazy Dog. No.
Restaurant?
No.
Anyway, cut
Sorry,
them in
man.
half, roast them, olive oil, some Romano cheese,
Dude.
capers, croutons.
There you go. Dude,
Good way to do it.
that sounds yummy. All right. If we also know that 4% of Americans think that chocolate milk comes from brown cows and that Brussels sprouts are the best vegetable. Okay. Do we already have a symbol that means this first piece? Chocolate milk comes from brown cows. Did we already set up a symbol? Yes. What symbol did we use? So C. So this has the symbol C. What symbol should you give Brussels sprouts are the best vegetable? What symbol do you want to give that? B. Holy shit. Okay. Now you see why I didn't choose B earlier for brown cow milk thing. So can this very first sentence, can you write that mathematically? It's the probability of, right, 4%. So probability of what? What is this? C. And B. And what is that? They tell me what that is, don't they? What is the probability of C and B? They just tell me. 0.04. But I give it symbols because now I have to use a freaking equation, right? What else do we know? Let's see. Now here's the question. What's the question in symbols? This question right here. Can you write that question in symbols?
C,
Almost.
B over T.
No. B given C. Now, can you look up real quick, if you don't remember, can you look up real quick, what would the formula for that be? What's the formula for the probability of B given C? Give everybody just a second, sorry. Can you find that?
P, A, and B.
Probability of
C and B
C and B, sure.
over C and C.
Good. Do we know P of C?
Yes.
Yes. So P of C is 0.07, right? So how do I really want this to make sense. You're going to see a homework problem. We're going to look at it in a minute, just really quickly. They're going to give you a bunch of percentages, blah, blah, blah. If you give them all symbols, and then they're going to ask you a question, write the equation for the question, and now you can throw the shit you know into the equation. So I know what C and B is, probability C and B. It's 0.04. I know what the probability C is. It's 0.07. So then what do I do with these? So just, 0.04 divided by 0.07. So if you first read through that question, you're like, how the hell would I know, Jeff? Well, here's how you do it. You catch each of them. You give them a math symbol because your math equation is right there. Now you know where to put stuff. This is an example of where you really do need the formula, because I didn't tell you how many people do anything. I just gave you percentages, right? I'm like, oh shit. What is 0.04 divided by 0.07? 5714? I got you. 0.5714? Okay. All right, maybe. So, oh yeah, let me do this. I want to show you that one problem I was talking about. I finally found my book. I had packed it away. I love it. Where was the first one of these? Doobie-doobie-doo. I don't remember. Doobie-doobie-doo. Here it is. I think. No. Here. Okay. Here's one of them. Number 80. The mistake people make is they sort of just go, okay. Probably see, okay, do I have a formula for that? No, I don't, okay, I don't know what to, so, when I give you, do you see all the percentages? Can anybody tell me how many percentages are given?
68%, 78%, and 79%.
You missed one. And this is evil, I'm being evil, I have to read through and see this one. So that's 60%. Okay, so they give us 4 things. The first 4 questions are those percentages. They just tell you the answer. Do you understand? People try to do work for this one and this one. Of course you do, because you're in a math class. And there's a math question. You got a formula for it. You don't need it here because they just get. So if I give you this people do this percentage and this percentage, then you just stop and go, before I look at any questions, let me just write the math. What is 61%? Look at how they define things. 61% would be the probability of what, based on how they define things? So let's see. California registered voters approved of allowing 2 people of the same gender to marry and have regular marriage laws apply to them. Yeah, that would be California registered voters who support same-sex marriage. So that would be the probability of C, right? That's 0.61. Let's do one more, because this is one of your homework problems if I remember correctly. Among 18 to 39-year-olds, the approval rating was 78%. So what do you know about the person from that sentence? Among 18 to 39-year-olds, the approval rating was 78%. Don't we know something about the person we're talking about? Could they be 48? The person we're talking about? No. So we were given that they're 18 to 39. What's the symbol for that? We're given that they're 18 to 39. And the probability, the approval rating, the ones who support, so this would be what 0.78 is. So that would be part C. Okay, maybe. So you have to read through and use the symbols they give you to identify them. Because now, like in part G, you have a formula for that. If you've written down all the things, you could just write the formula for C and B, and then you could just put the stuff in, calculate it. Done. Okay, maybe. So just like in algebra, what's the very first thing you have this long problem? You try to go, okay, that's my x value, and that's, so now I know where to plug it in the formula. It's basically the exact same idea. Okay, maybe. So I'm gonna let you guys get to that. We'll see. By the way, just so you know, the test is tomorrow. The first 20 minutes or something are going to be devoted to questions and whatever, right? Whatever you give me today, I will try to get graded by tomorrow, and I can give it back to you. I still have some that I haven't finished because you turned in a lot of shit yesterday. So I'm like, anyway, which is great. Please turn all of it in. Give it to me. Yes.
So if we get, if you give us stuff back tomorrow, we correct it, can we turn it in next class?
When are homework corrections due?
Day of the final.
Day of the final. So you can give it to me whenever the hell you want to. Yeah.
Probability gonna go to test?
Yes. Totally. Okay. Okay. That's one of the weirdest things, by the way. The problem we just looked at, because it's something you're not used to doing in this way. You're kind of used to it from algebra, but not using the symbols, probability of C and B, C given A, and all that kind of stuff. Okay. The other side of this, by the way, so the practice test, which I think I gave all of mine away. So if you don't have one, they're up in Canvas. The practice test was basically chapter 1 and 2, and then this is the practice for test 3. So one thing you can ask me today, so we're gonna we could take a break, or we could just go into review, because if we get all the questions answered, we can leave early if we want to, right? In fact, you can leave right now if you wanted to. If you're like, I'm getting an A on this damn test, I already know I am, so I'm just out of here. Because we're about to start the review part, right? I've got the answer key for this. I've got the answer key for the actual practice test that I gave you, which I'm not going to give you yet. So now it's just wide open to whatever you guys want to talk about. And before I do that, let's make a formula sheet, and then we'll jump into questions, right? Okay.
Keep the formula sheet for the test, right?
Yes, that would be so mean. Formula sheet, put them away, yeah.
How big can the formula sheet be?
Say again?
How big can the formula sheet be?
How
big can the
Oh,
formula
big.
sheet be?
It's as big as you want, as long as it doesn't affect anybody else. You can bring in this scroll, but you can only put on there the shit I say you can. It's not, you can't just put any damn thing you want to on it. So I'm almost certain some of you guys have had teachers that say a 3x5 card, you can put whatever you want to, and you're like, ee. Has anybody ever had that?
Yes.
Yes. If you haven't, you will. And I keep joking, grain of rice. You can put all the stuff you want to on a grain of rice. Okay. It's so stupid. So I'm going to tell you exactly what you're allowed to have, and I don't care how big the shit is you put it on, as long as it doesn't mess with anybody else. I'm cool with it. All right. Well, you will lose points if you put stuff on your formula sheet that I don't say is allowed. Let me say it again. You will lose points if you put stuff on your formula sheet that I did not say can be on there. Okay, good. Okay. Here, sleep. Okay. So chapter 1, everybody's favorite, just definitions, no formulas. Chapter 2, we get our first little formula here, right? If I were you, I might not even write that down, because that's the formula for finding the what?
So, Or no, that's the,
The mean, specifically for a population, I like it. So if you want to, you can write this one down. Same formula, but now it's for a sample. So population in the early part of the course is Greek letters. Sample would be our letters. I like it. Of course, we stole our letters from other people, but the very next formula we got was for the standard deviation. And you can write this down. Let me write this. You can write this down. You can either do the one, what's this known as? Before I take a square root is the
sigma squared.
start with V. Variance. I love it. So before you take a square root, it's called the variance. Let's see if anybody remembers any part of this. What goes in here? And of course we had to square it because we wanted the negatives to go away, so that it would add 0 for everything. And then you can write. So you can write this. You could put this. These are the same formula, yes. One has not been square rooted. One has been square rooted. So however you want to write that down. By the way, you should double check the formulas you've written down against handouts or the textbook, because I don't know if you noticed, I don't write well. So if you misread something I write down, kind of double check. What is it for sample? What's the symbol become? And of course the other immediate difference would be what would go here,
X bar.
X bar. And of course the really big difference would be what goes here. -1, I love it. So we talked a little bit about why that is. And then you can do S equals square root. And again, these are the same formula. If you don't want to write it down twice, you don't have to, but it's a little bit nice to do that for yourself. All right, and then we had the first immediate use of a standard deviation is to create a z-score. And something I didn't really write down, but it kind of makes sense, is that's for a population, this is for a sample, yeah? By the way, that's an S. It's trying to be all nifty of an S. It's not a 5, yes, it's an S. Poor little dude. Okay. There is another formula that I don't think, it's not a different formula. It's actually this one. Let me put this up here and let's do a problem, because I don't think we did a problem like this. If I take this one and I solve for x, let's see if you guys see this. I multiply by sigma, yes? And then I'm going to add the mean. So I'd end up with this. This formula would be if I said, if the mean is 10 and the standard deviation is 2, what data value is 3.14 standard deviations above the mean? So you would put a 3.14 in there, you put a 10 there and a 2 there, bam. Anybody remember the question I'm going to ask on every test?
Z-score.
What does the z-score tell you? This formula actually is a sentence that answers that question. The z-score is the number of standard deviations from the mean to the data point. Do you understand? So you're not allowed notes, but equations are notes, and I allow you to have equations, so I'm like, oh shit, I guess you can have notes. So if you're going to read equations like sentences, you're going to be able to answer quite a few conceptual questions.
So for the formulas here, I'm just next to it, I'm saying, okay, this is the z-score for sample. Is that allowed?
No,
Right
no
now?
words,
No word.
no words.
I like it. But isn't a Greek letter and a Latin letter a word as well?
No, they're letters. No, I mean, so. You're only allowed to have this right here. So don't put down your population, don't put over your variance, don't put over here. Use the lists to blah, blah, blah. No notes, nothing else. So I don't make you memorize formulas, I make you recognize formulas, right? And this is what I said the first day. I said the more you understand the idea, the more you know when to use which formula. sample, gonna use this formula. N minus 1 is an adjustment for it just being a poor little sample. That's an adjustment, right? So the more you understand an idea, the more you're like, okay, now I use this formula, now I use that formula. Okay. And some of you guys are like, that's my problem, man. Don't understand the concept. All right, well, then come see me. Yes?
What is variance used for again?
Oh. Variance is going to come up later. It does have a purpose. Let me see, how do I say this? If I took everybody's age and averaged it, I would get the average age in you, correct? Ooh. If I took 2 people at a time and averaged the average of 2 people at a time, would I get a different number?
Yes.
Think about it. Did that change the people? Did everybody suddenly become older because I took 2 people at a time?
No.
Nope. So if I take 2 people at a time, get their average ages, and then average those, why would it be bigger or smaller? It's still the average of everybody, correct? You guys kind of follow? If I take the standard deviation of groups and then average them, it actually is not equal to the overall standard deviation. If I take the variance of each group and then average those, it does equal the variance of the whole population. That's way more than you have to know right now. But that is the, sorry, you answered the question? I can't remember. Yes. That is one of the main things about this is, what's the name of it now? I forgot. Ushgrit, I can't remember. There's a certain name for this being, it targets the actual variance, where the actual population parameter. This does not target the parameter. More than you had to know, I'm sorry. Okay. Now, so this is chapter 2. And then chapter 3 are just our probability problems, right? Our probability formulas. Probability of A plus probability of B minus probability of A and B. Probability of A given B equals probability of A and B. Probability of A. Probability of A and B. This one's going to suck a little bit because there's 2 ways to do it, but Chumbawamba. I'm sorry, that's a little low. Can everybody see that? Yes? Okay.
Is that a division symbol between A and B?
No, what symbol is that? Given. So straight up and down. Yeah. So it's not division, it's given.
Oh, no, I mean like, P, probability of A or B, probability of A, and there's a symbol.
Oh, probably of A plus. Let me put these up here too.
Sorry.
No, you're good. A or B. Oh my gosh, this dude is dying. So what are you like? Ooh. You're fabulous. I love it. Probably of A or B is probably A plus probably of A minus probably of A. So it's basically add. The given, you just reduce your denominator because now you're throwing people out. So now the denominator is based on what was given. And then the and is actually just built from this equation. Who remembers if A and B are independent, what would the probability of B given A be?
0? 1.
If they're independent, would B give a shit that A happened?
No.
So the probability of B given A would equal the probability of B. It wouldn't change. If I ask you, are W and F independent? That's exactly what I'm going to say. You would just look at the probability of W versus the probability of W given F. If they're the same, then W didn't give a shit that F happened. That would, we call it independent then. That makes that, math people, we sometimes name things well. Very often we don't, I agree. So independent just means, if given one thing happens, if this guy doesn't care, this guy doesn't care, meaning it's still the same as the probability B, they're independent. You didn't care. If I'm given that A happens, the probability B given A is different from probability B, then obviously it was affected. Then they're dependent. Really want that to make sense. So when I ask you, are these two things independent, you compare numbers. You don't write a paragraph. If you start writing a paragraph in response to that question, you are wrong. It is not an English question. It is a math question. Are these two numbers the same or different? Okay. All right, that's a lot. So now I'm just going to open it up. It's wide open. We could look at this practice probability stuff together. We could look at problems from the practice test that I gave you before. We could look at homework problems. We could sit and stare at each other. We can go on Amazon and get shirts with lemons on them. Now I want one. Or something else if you don't want to give Jeff Bezos any more money. Like, same name, a little different income. So what do you guys, it's totally up to you. If nobody's asking a question, the floor is yours. Yes, sorry, I'll come back to you.
So, when we were trying to find quartile 3 on the test, what is, I don't remember the way that you
Oh.
do it?
Third quartile means what percentile? 75th.
Oh,
So then you just do 75% of how many data points? Right? And what are the two things that could happen for any percentile? If I do this, the percentage of the number and I get a whole number, what would I do?
Want to write this on the board?
Oh, sure. Has everybody got, well, let me leave this up here because I think somebody just came in. But those are all the formulas you can have on a sheet that you can use during the test. By the way, if you ever come to a test and you're like, oh shit, I did not bring my formula sheet, just tell me, I'll make one for you real quick, right? Not that big of a deal, but I kind of want you to have your own, but you know, if you come and you're like, oh, I forgot, don't just write down, I didn't have my formula sheet, so I couldn't do anything. No, good Lord, just tell me. Yeah,
So we can only write formulas on our formula sheet?
only these.
So it should look like this, just formulas.
Bodacious. By the way, any formulas you think I missed? I'm wide open. Now's the time for suggestions. Yes.
Can we have like the range formula?
I'll come back to the question, by the way. I'm sorry. Say
Can we
again?
have the range formula or no?
No. Come on, what's range? High minus low.
How minus low, high minus
No.
That's not range?
Nope.
That's class width.
Class width. Yes, okay. So class width is range divided by number of classes. And range is high minus low. Those two I'm going to make you know. Because I'm a jerk. That's on camera. Yes. I'm sorry. Oh, good.
Do we need to get your quartile rate?
No, I'm not going to ask you that. Yeah, it's not used like a ton. But I do, in the homework you have to do it because I want you to be aware that it exists. Yeah. Okay, now, what was the question again? I'm sorry. So much is happening.
Oh, quartile 3, but you pretty much told me.
Okay. Oh, but you wanted me to, what was I going to write down?
The 75th percent.
Oh, yeah, okay. I don't have paper, hold on. Here we go. I don't like the overhead, but it's okay. All right. All right, so what was I going to write down? So if you have to do P something, and let's say you have, you have N things, and let's make N equal to 117. So how would you find the 23rd percentile? 2 steps. You would take
23% of 117.
23% of 117, 0.23 times 117.
And then if you get decimal, you round up, right?
Yeah.
And then you take that data point of the list.
Okay, so help me out. What's 23% of 117? Help me out. Why did I pick these numbers? I don't know. What's 0.23 times 117? 26.6? 0.91? Okay. So then what do I do? It's a decimal, so what do I do?
27.
So then the answer will be the 27th number. Don't write 27th number. Go look at the list of data and get the 27th number. Now what's really, really important about your list of data? It should be in order. Otherwise you can make any percentile anything you want to, which doesn't seem good. So what if I wanted to know P 30 and N was 600 things? What's the steps? I would take 30% of 600. Good, 0.3 times 600. 180. What would that tell me to do? I didn't get a decimal, so what do I do?
Average.
Average the 180th with
109.
181st. If you get a decimal, you round up, take that number, you're done. So you're sort of like, please give me a decimal, that'd be awesome. 1.7, okay, the second number is the answer. If you get 4, you're like, oh shit, what's the fourth number? What's the fifth number? Let me average them, right?
Can you remind us how to take the mean on the calculator? 'Cause I don't know if
Oh, yeah. So,
there were a lot of data
I'm sure you guys have noticed, am a show your work by hand kind of guy, for the most part. But I do want you to be aware of how to check your work in the calculator, because these things cost enough money. Oh man, you got all the calculators in the world, Jeff. Okay. So let's all put some data in here. So real quick, go to your list, clear your list one at least, and let's use the same data real quick. Let's do 18, 15, 24, 17, and 9. So what's really, really cool is there's one button to get to that when you press it, it gives you a ton of information. All of which I have to see the work for, but you can check your work. So if I go, does anybody remember how to get there? Stat? Because I want to calculate something with my data, right? Calculate one var stats. I would use 2 var stats if I had, for example, later this semester we'll talk about the number of beers you drink and the grade you make on the test the next day. That would be 2 sets of data, and I can analyze how they interact, correct? We only have 1 set of data. I have 1 list of data. That's 1 variable. List 1, no freaky list, calculate. Did everybody get this? If you're playing along. What's the very first thing mean? The mean. I kind of gave it away with the question. The calculator will always say X bar. We're the humans. We have to know if it's actually a population. If that was a population I put in there, I know it means mu. The calculator's dumb. Piece of plastic bullshit. It's going to say X bar. It doesn't know. The next important thing, these two don't really matter to us too much, but what does that mean?
Sum of X.
The sum of all the values. I love it. This is the sum of all the values squared, just because. If what we put in was a population, what is the standard deviation? Yeah, it's the 4.841, right? Because that's sigma, that's a population. If what we put in was a sample, I'd use S, correct? Man, you are really, wow, okay. You guys semi with me? So again, we're the humans. Calculator will spit out number, and then we're like, oh shit, I have to make sense of what this is. So it's gonna give me both. Why? Because it doesn't know. It has no idea what the hell that is. Sample, population, like, here you go, human. What's the last 5 things it tells me? 5-number summary, which you need to create. Yes, box and whisker. Right? So if I give you a problem and you try to get the Q1, Q2, Q3 high, and you're like, and then you check it and you're like, oh, it's not the same numbers. Don't just copy these. Don't just copy these. Just create your, I'm going to give you more credit for basing things off the work you did than from copying stuff out of the calculator. Does that make any sense? If you can, that will help you maybe catch a mistake. If you catch a mistake, you're like, okay, good. Now I can get the right answer. No worries. Okay, maybe. So you definitely have a way to check a lot of what I'm going to ask you to do very quickly from your data if it's in the list. Is that what you asked? I can't remember. Did I address everything? Okay. And of course, we talked about how to use the lists themselves to do like x minus the mean squared to try to work towards doing this formula here, right? There's that whole handout I gave you. It's got all that stuff on there. Okay, hopefully, yes.
Please do one of those problems.
Sure, yeah. In fact, let's do the data I've got in there, maybe. Yeah, because what was the mean again? It wasn't anything too evil, was it? It was a little, no, it was nice. Okay. So everybody's got this data in your calculator, correct? Okay, so let's say I want to calculate the, that's what that is. Do I have any more? Hold on. Here we go. Got some more blank paper. All right. So say I want to calculate the standard deviation for this data up here. First thing is, how do I sort that data? I know it's a small data set, but just to remember. How do I sort that? How do I make the calculator sort it? Let me say it like that. I hit what button? Stat? Sort A? Now if you hit enter right now, it's going to be like, what? You got to tell it which list. So now when I go back in, it's in order. Yay. Not a bad idea to order this stuff. 9, 15, 17, 18, 24. Now, if I'm trying to use this formula, and you're looking this way, aren't you? Look that way. If I'm trying to use this formula, what do I want to eventually get a list of? What does this formula need me to be able to add? I want to add up these. That's what it says. Add up these. Do I have a bunch of these yet? Hell no. Right? So let's kind of work our way there. I need x minus the mean. So I want to go to list 2 now. That's the second list now. And I want it to be x minus the mean. So if I go up to L2, I can define the whole thing. And the mean was 16.6. Okay, so now if I tell it L1, that's where my x's are, minus 16.6, it'll just do the whole damn thing. All right, backpack. You're drunk. Okay. No, I'm drunk. So these are these are actually called the deviations. This is how much each data point deviates from the mean. Not important to know really, but it kind of leads towards standard deviation, where that comes from. If I added those up, what would I get? You don't even have to do it. You should know. What would I get? 0. I'm always going to get 0 if I add those up. So that's where I have to go and do what to them? I want to do what to them, make that negatives go away. Square. So I'm going to go up to L3. I'm going to say, hey, take L2 stuff and square it, please. And again, this is all on that handout on standard deviations that I gave out from section 2.7. So now, how do I get the number that has to go up here? How do I get the number? Let me make sure the people at home can see this. That I want to put up here. Well, what's it telling me to do? It wants me to add up these. Do we have a bunch of these? Yeah. List 3. So you can either copy them down and then put them in the calculator, that's fine, or you can hit second mode to quit. I want to do something to one of my lists now, right? So see how it says list above stat? Second stat, I want to do math to a list. I want to sum up a list. I want to sum up list 3. I love it. Like that's good for you, Jeff. Yes.
Where's that little sum button?
Oh, let me do it again. Yeah, stop it. You can do it, Jeff. Okay. Above here, see where it says list?
Yeah.
Why do I know to go there? Because right now I want to add up list 3. So I want to do something to a list. So hit second stat to get to list. I want to do math to a list. I want to sum up a list. And then list 3. So now what goes here? Oh, my battery's almost dead. Oh, man. What goes here?
117.
Yeah, because that's the sum of all these things. So we're going to see more formulas later that have a sum sitting in front of stuff. But that just tells you, make a column of this stuff, and then it can add it up. And that number goes there. So part of any math course is just getting to understand its terminology, right? We're all catching up with all these shortcut ways that some old dude way back in time stole from some woman who actually did the work and then gave it to as their own, which unfortunately happened a lot in mathematics. Divided by what? How many data points are there? 5. So I'm going to divide by 4. I love it. So let's see, what is 117.2 divided by 4? I get 29.3. That is the what? What? That's the variance. So I want the standard deviation, so I take a square root. Second squared to get a square root. Or you just type in 29.3, it's not that big of a deal. And I get 5.413. Everybody cool with that? Yes.
What is the difference between variance and standard deviation?
It literally is, the variance just hasn't been square rooted yet. That's it, right? The variance just hasn't been square rooted yet. That's it. Now somebody else asked me what purpose does it serve, and I gave the most important immediate purpose it serves, and we'll talk about that later. But so why do we even calculate variance? It has a purpose. But for us right now, it just means we're not done. I haven't square rooted yet, right? Okay.
What was the equation for this 3 again? Sorry.
So if we go back to list 3, I want list 3 to, I just want list 3 to be list 2 squared, right? That's literally what I put in. Put in list 2 squared. No, Jeff. That's what you get for looking in the wrong place. Squared. There you go, buddy.
Oh, okay. I just got confused.
And again, on that handout, I actually told you what formula to plug into each list. Can you use that on the test? Well, no, but it's a good place to go. Remember what those are. Yes?
Okay, 29.3, what is that?
Yeah, what is 29.3 again? Variance. And then when you square root it, you get the standard deviation. And real quick, do you guys remember when we did 1 var stats, what did we get for the standard deviation? If we're assuming this is a sample, which I did. 5.413, holy shit. Do you see that? You can check yourself. Check yourself. Show me what you are working with. Okay. Yes.
So we were following the x equals the square root.
Yes.
Okay.
Totally.
Pointing to the top.
So on the test, I will be very clear. The homework isn't always, but if you're like, is this a population or a sample? It's a sample. If you're like, I'm not sure, it's a sample. Because if it was a population, they would be like, it's a population. If I'm a statistician and I have all the data, I'm like, holy shit. I'm gonna let everybody know this is a population. So if you're like, I'm not sure, it's a sample. Just assume it's a sample if you can't tell. Trust me.
So if it's not everybody, it's just gonna be a sample, right?
Yeah, if it doesn't say, if it seems to not say, it must be a sample. Yeah. Okay. I try very hard on my tests to actually say it's a sample or it's a population. Okay, because I'm not trying to make any trick questions. Okay. I love it. So that's like number, I don't have any practice tests with me, darn it. I think, was it number 2, number 1 had a, oh yeah, that's right. I have to do this with you anyway. I ended up not putting that on the key. So we're gonna do this together, so let me bring that up real quick. When I say real quick, I mean, you know, not very quickly. Okay, I got the password right. No, it's here. All right, so this first data, I think it was E and F I didn't do. Just because I'm the teacher, I don't have to. No, because I just ran out of room, whatever it was. Okay, so let's try to do this one semi together. So let's all put this data into our calculators. If I would have been smart, I would have just done this from the beginning. Oh, sure. This one's I haven't seen dead. Make sure that's got battery. Huh? I got plenty. Make sure it's got battery. Make sure it's got battery. Charge you on the fly. I'll catch up to you guys. Go ahead and put the data into list 1. Is everybody cool with, in lieu of a break, we'll just keep going and then maybe leave a little early? Or if you need a break, obviously you could just take it whenever. Okay. You're all like, you had me at early. All right, so okay. Okay. Let me see. I'm going to switch this over. Well, I guess I could do this if I want to be neat. No, I don't need the PC. What am I doing? I wish I knew. Okay. So I'm gonna go ahead and sort this. It just sort of makes it, you don't have to sort this, I didn't ask you to, but I think on this problem, like, you want to sort it because you have to do a stem and leaf and all that kind of stuff, right? Yes. So by this point, I would have sorted this already. So let me go ahead and sort this thing. Yay. Okay. By the way, if I had to make a histogram out of this, which I think we do, yes. How would I figure out the class width?
Range minus,
So be very specific.
data points.
Be more specific. So 63 minus 29 divided by,
Number of classes.
and how many classes would you want to use? 5 sounds good? Anybody want to use a different number? 6? I don't know. I would use 6. Just because I want to be contrarian.
Kind of
Yes.
a question out of nowhere. So it's about quartiles and percentages. If you're in like the 70th percentile of something, does that mean you have a greater score or whatever or a greater score than 70% of the people?
Yeah, yeah.
Okay.
You scored higher than 70% of everybody else.
Okay.
Whatever
not,
that is.
Not 69th because it's like, let's say you are the 70th percentile, let's say there's 100 people in a room, and you're the 70th percentile for whatever, like a test grade, right? You're still, because the way like mathematics is, or for this is like defined, technically, you score greater than 70% of people, even though you are the 70th person.
The 70th percentile is
Right.
higher than 70% of all the other things.
Okay.
The smaller the sample gets, the less immediate sense it makes, because then the 12th percentile is the same as the 13th, is the same as the 14th. So,
Right, okay.
you know, in that sense, it's a little less perfect. But that's because you have a very small sample, and everything kind of goes to shit with a small sample.
Okay, thank you.
Yeah.
I was doing the homework and that thought came to mind.
Yeah, so in the homework, there's a lot of things like there's a woman who's in the 85th percentile for wait times and the DMV and all that kind of
Yeah.
stuff. I'm getting people answering that very strangely. I need it specifically. 85th percentile, you should be able to say something about 85% of something is somewhere. You should be able to say it like that, because percentiles are always, if I'm in the 58th percentile, my score, whatever that is higher than 58% of everybody else. That could be bad or good, depending on the situation, but that's all it means. That's all a percentile could possibly ever mean. Okay. The first thing I have to calculate, oh, go ahead.
Okay, so, the high minus low over like the, number of classes, with this, do we just make up the number for something?
Yep, it could be, so I basically just told you earlier, it's 5 to 10, but we're going to use small enough samples, we're never going to use more than 6, so 5 or 6 classes, whichever one you feel like. So I could be grading, and you could also start either at the first data point or a little bit below that. So it's always exciting to grade these, because then everybody's histogram looks a little different. Now, I want to do the same thing here that we did earlier. So what do I want to do? First thing, I have to calculate what first? Before I can calculate x minus x bar, I've got to know what the hell x bar is. Now, if you hit stat calc 1 var stats, it will tell you x bar, right? Because I'm a weirdo, I want you to actually show me work, meaning you just take 685 divided by 15. You guys see what I'm saying? Okay. And again, why do I do that? Just because I want you to remember what goes into creating that number. I want it to be less, oh, I see that number on the screen, and more what actually goes into it, reminding you it's an average. So anyway, so you do get 45 point. Okay. So let's write that down. So now I'm going to do a different thing. X bar is, let's say 45.667. You don't want to round it too much. So now, how do I construct what I need for the? I know what X bar is now. How do I construct what I need for this formula?
To 15.
And 1 minus.
Yes, so I want all the x's. So go to L2. I want to take all the x's where are the x's? L1. and I want to subtract from them the mean. Kabam! Now, real quick, if I add those up, what should I get? 0. Let's see. Quit. Go into my list. Math. Sum. L2. Why do I not get 0? I got really close to 0, right?
I'm sorry, I got a little online for a second. L2, you're doing list 1 minus what?
The mean, which was the 45.667. Somebody. So list 2 should definitely add up to be 0 because the mean cuts it in half. So the negatives and positives should cancel each other out. Why didn't it come out to be exactly 0? We rounded the mean. There you go. So, but it's really damn close to 0. That's a good little check to make sure you're on the right track. Coming back to our list. Now I've got x minus x bar. They add up to be 0, which is really not useful. So what do I want to make L3 do? Square L2. And again, the reason we do that is to kill the negatives. Shlabam, which is again why doing a square root at the end makes sense. I got to undo that square. If this is the number of dogs people own, this is like Picasso dogs, little cube dogs. That is disturbing. Let me square root this, not cube, but square dogs, little square dogs. Let me square root that bad thing. All right. So we've constructed list 3 are all x minus x bar squares. So now I just have to do what to list 3? No. No. Sum them up. So let me go second quit, go to list, go to math, go to sum, L3. So now we take Scheisse. Come here, you. Merge. So s squared equals the sum of x minus x bar squared over n minus 1. So what am I going to put here? This whole thing is 1029.333335 divided by 14. I love it because there were 15 data points. So in the calculator, I just have to do this. Hit the divided by symbol. The calculator assumes I want to divide the last number I had by 14. So that is the what? Blah, 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 blah. Holy shit. Come here, you. So then the last thing I do is I take, square root. So again, just to remind you guys, if I hit the square root symbol and then hit second negative button, that means the last number that's on the screen. Bam. So I don't have to write all those freaking decimals down. 8.575. Okay. What does that mean again? What does that mean? What does that mean?
That is, that's the standard deviation. So.
What's
with
that mean?
Are you asking like
What's it mean? Yeah.
That's the amount of steps.
Not quite.
The distance from the amount of steps.
This actually is the step size. The z-score tells you the number of V's from the mean to data point. This tells you the average distance the data points get away from the mean. Really? So standard deviation is how far all the data points get from the middle on average. You with me? So again, why would I not use miles to measure the distance between two people in here? Because what's the average distance apart people are in here? Is it on the scale of miles? No, it's on the scale of at most feet, right? You guys with me? So standard deviation says, okay, here I got this data. What's the average distance things get away from the middle? That just makes sense to use that as a unit of measurement. Then I can say, well, this person is 3 standard deviations away from this person. All right, so they're relatively far away.
Whereas you guys might be 0.5 standard deviations apart or something like that. You guys kind of understand? No? Okay. How do I check this in the calculator?
So standard deviations like the unit of measurement.
Yes. But if I ask you standard deviation, I want you to say that it is, because it is a unit of measurement, totally. But what is it technically? It's the average distance from the mean to all those data points.
Oh, because it's like you have all these sets of data points, right? And some of them are extremes, some of them are really close to the mean. But the standard deviation is like the average distance of like that really close one and the really long one, right? But if you're taking all of
Yes.
this into account.
Yes.
Okay.
Yes. So how do I check my answer we got? How do I check it real quick?
The number.
Stat, yeah, calc, one var stats. Oh no, I got 8.28, oh no! Oh no, how dramatic can I be? Why is that, I mean, which one am I supposed to be looking at, of course? Yes, okay, so we got 8.575, kick ass.
Why population sample is like different, the standard deviation?
Well, population I divide by n, sample I divide by n minus 1, so they're gonna be a little different, yeah. Yes,
Can we just go over this problem on the Instagram?
with the what now?
With this, because this problem on the worksheet, like it says to make a histogram out of it. Can we just
Oh,
go over
I've
it?
got that on the answer key. The reason I'm doing this with you guys is because I didn't put this on the answer key. Yeah. Going back to the test. So that was part E for the most part. The only thing I left out was the range, but that's pretty straightforward. By the time you get to part E, you would have done the range already, right? To get the class width. Part F, what percentage of the data is within one standard deviation of the mean? Let's calculate that.
68%.
You could only say that if you knew that they were distributed how?
Normally.
Do I say anywhere that they're normally distributed? Nope. A good try. So, we don't have to rely on a freaking theorem because I can just count, right? Okay, so everybody got the question we're going to do, part F? Let's go back. Oh man, so much technology. Okay. Help me out. What was the mean? 45.6, blah, blah, blah. If I go one step up, where do I end up? How big is each step? 8.575. So if I take one step up, where do I go? Is everybody with that? So I want to know within one standard deviation. Well, what does within mean? Within mean, it means up or down. If I want you to guess my weight within 10 pounds, you could be off by 10 pounds up or off by 10 pounds down, correct? Within means up and down. So if I go down one step, where do I end up?
37.092.
092, blah, blah, blah. Okay. So can somebody help me out? The way I do this really, normally what I do is I just count how many data points I don't catch. It's just quicker. So can somebody tell me what data points do I not catch?
Anything beyond 54 and below.
What's below 37? Let's see, 29 and 34, right? There's two data points there I don't catch. What do I not catch up here? Oh shit, I can't show everything at once. Did I give it?
55 and 60.
There we go, buddy. You can do it. Come on, you can do it. Oh my god. Okay, all right. Sorry. Where are we at?
55 and 60.
55 and 63. So there's four things. You guys with me? There's four things not in there. And there are 15 data points. How many things are in here? 11 out of? Can you make that a percentage? Yeah. Yeah, see? It's summer. I'm a loopy. So I get about 73.33%. If it was normal, what would that number be? 68. Could this still be approximately normal? Yeah, it could still be. It doesn't have to be exactly 68 if I'm approximately normal. How could you really tell? Make the histogram. which is the other part of the problem, because then you can see if it kind of looks roughly normal. You guys okay out there? I know this is a lot, but we all signed up for this, so we have to remind ourselves that. Okay. Okay. So let me do this. Let me give you the answer key for both things, but I'll give you the answer key for the thing I call the practice test. I'll give that to you first here. And I hand wrote all of these. No, I didn't. Copied it in color.
I'm gonna say, good on you if you actually did that.
Oh my God, no, holy shit. I'd be so not wanting the last copy, because oh my God, at that point, my writing would be nuclear grade bad. Go back there. All right. So you can see there, I got E and F in class, so we just did those. E and F in class. Okay. Troy and Abbott in the morning. Now let me give you this. This is the answer key for the, it used to be called what I called the double quiz. Too bad. So it's that extra practice from chapter 3, that other handout I gave. Before I go too far, if you don't have time to do the practice test, it's not required. Do not turn that in, dear God. I just gave you the answer key. I don't need that extra paper, right? If you don't have time to do it, don't do it, but don't do this. Yeah. Yeah, I would have done that. Yeah. Don't give yourself false confidence by just agreeing with the work I did, correct? By the way, look this over. I'm averaging about a 97 on my answer keys. So I'm human, so there might be a mistake somewhere. So let me give you this one. This is for that probability practice. This one I decided to type up, so for once you could read what was happening. Oof. So now it's basically anything you want to talk about. If there's something, even if I've said it like 10 times, do not apologize. Just say, Jeff, I still don't understand blank. Yes?
I'm still confused on like the histograms and the frequency table.
Okay,
Yeah,
okay.
so just like,
So the very first most important thing about histograms is constructing the width, because that just governs everything, right? So the width, of course, is going to be high minus low. In this case, I used 5 classes. I don't think I said to use any, right? So you could have used 6 classes. Your histogram might end up looking a little different. So I got 6.8 and I rounded that up to 7. So unfortunately, oh shit, that sucks a lot. Damn it. I love my printer. So that's going to be the first data point, which is 29. And then the next one is 7 up from that 36, right? So if you guys want to write that in. So this is 29, plus 7 is 36, plus 7 is 43, plus 7 is 50, plus 7 is 57, right? If this is 36, that must be 35, and so forth. Now, if anybody's doing the inequality method, cool, do it. It's a little easier as long as inequalities don't confuse you, right? Yeah.
Okay, so we don't have to start like 0 or 1.
Oh, hell no.
And it's the same with the stem and leaf, right? You can just,
Oh, hell no. Yeah. You start wherever your data starts. Yeah.
alright, and if there's like a gap in the middle, like let's say there wasn't any, like there wasn't 34 or 38.
Sure.
Do I skip 3 or do I have to put 3?
You would put a 0 there. That's all. You can't skip anything. You have to show it's empty. So in a stem and leaf, don't go 2, 3, 5, 7, because there is no 40s. No, you put a 4 and you leave it blank.
Okay.
Put a 6 and you leave it blank, because that shows me there's gaps. That shows me how spread out the distribution is. Same thing here. You don't just not write a class if it doesn't have anything in it, because it's going to be an empty class. It's got to be shown as empty. It's a missing tooth. Yeah.
Why do you start you might have just answered that, but why do you start with 28.5 when you do your history?
Oh, so if you do it the textbook method, right? If I just did 29 to 35 and then 36, there would be a gap between 35 and 36. So how do we overcome that? We use, instead of using the limits, we use the boundaries. So I go down a half and up a half. So 29 and a half to 35 and a half. So if 20 and a half to 35 and a half, what would this be? 35 and a half. Now the 35 and a halves line up, there's no gap. And I agree, that's dumb. I want you to understand why I just said that. I don't like that. That's bullshit. It's dumb. It's the textbook method. It's the way that a lot of people do it. So it's completely valid. I just think it's dumb. Yeah.
So if we did the histogram with like the numbers that we used for our table, like 29 to 63, for our histogram, would that be wrong?
If you do, I'm sorry? If you use 29 here,
Yeah.
and this is what your table looks like? Wrong. Totally. So wrong. So if you did these classes, if your first class was 29 less than or equal to x less than 36, which is the other way to do this, then I could put 29, 36, blah, blah, blah. Because that would be the actual boundaries of that class. So if you use the inequality method, the numbers I see are the boundaries. If you use the textbook method, the boundaries are hidden. They're half up and half down. Okay. I'll lock it. Yes?
How did you find the last row of the frequency table?
Oh, you mean the column?
Yes.
Oh.
The last column.
There's 15 data points. How many out of those are in this first class? 2 out of 15? Yeah.
Oftentimes in the textbook for homework and stuff, when it says frequency table, it shows like cumulative relative frequency.
Oh, yeah.
Are you gonna want us to do that?
I'm never going to ask you for that.
Okay.
But in the homework it's there. I just want you to know it exists. There's actually a certain graph that we didn't cover that kind of shows the cumulative frequency, but it is so infrequently used. Yeah, it's always either increasing or staying flat, because you're always either adding to or not adding. You're never subtracting negative percent. Yeah. Yes.
I had a question, but it's about our first quiz. Is that okay?
Sure. Yeah. It's wide open.
For one of them, it was talking about the level of measurements, and the question was, number of cars stopped in a day by a car.
Sure.
So then, would that be like nominal?
No. So let me ask you a really silly question. So the thing was number of cars stopped in a day by a cop. Is that a number or is that a category? Yeah, a number. So it can't be nominal or ordinal. Those are categorical. Those are qualitative. It must be interval or ratio. So the very first thing I do when I realize, okay, this is really numerical, I just say to myself, does 0 make sense? So if I said this cop stopped 0 cars, what would that mean? Does that mean they stopped no cars? I know you're like, but yeah, 0 means what it's supposed to, right? It means the absence of blank, the absence of car stop. So right there, it's what? Ratio. If 0 doesn't mean what it's supposed to mean, it's interval. And you can double check by subtracting. So I want you to realize, if one cop stopped 6 and the other cop stopped 2, 6 minus 2 is 4. It makes 4 more cars stopped, right? So why isn't the answer interval? Because it's 4. 6 divided by 2 is 3. 3 times as many cars stopped. Physical sense, ratio. You go to the highest level you can. Nominal is the lowest. It's just names. Ratio is the highest. You can do the most shit with it. Okay. Yes.
I think also in the same category question. In the homework, it was about like lemons height or something.
Okay.
And I had a tough time distinguishing interval and ratio because ratio would make sense in the idea that like one woman's height minus another woman's height, it's like, the number it gives you is then, it's like how much taller one is.
Sure.
than the other. But at the same time, I think the answer might have been, is the answer ratio to that?
Totally,
Because.
all day long.
But then it's, you know, someone being 0 tall, 0 units tall, it's like they don't exist.
Totally. I
But-
go
but
out,
that-
I go out and try to catch fish, and I say the biggest fish I caught was 0 inches long. That's another way to say you didn't catch any fish. It's
Okay.
absence of thing.
So
So
we-
0 means what it's supposed to mean.
Okay, so when you say it makes sense, do you mean more like you can like parse the sentence rather than like would that happen? You know,
Say it one more time.
like because I guess I'm just having trouble wrapping my head around it when something counts as making sense. Because in my head, someone being no units tall doesn't make sense. 'Cause,
True,
you
true.
know,
But what would a 0 mean? It would mean that they don't exist. Or
Right.
what, even better, if somebody's 3'6".
uh,
Is that impossible for a woman to be 3'6"?
No.
Is it impossible for a woman to be 7 foot tall?
No.
3'6" doubled is 7 feet.
Uh-huh.
So this person is twice as tall as this person. Does that make physical sense?
Yeah.
Division makes sense.
Okay.
Ratio.
Okay.
But I understand.
Yeah. I'm not trying to be like
0 would mean. Not saying it's gonna happen. It's not you know. I met my friend Sally. You're Sally. She's 0 inches tall. Like, are you feeling okay? It's saying what would 0 mean in this case? Absence of woman, right?
Okay.
Absence of height. So it would mean what it's supposed to.
Okay.
Yeah.
Okay, so for the histogram, you did the 0.5, is that just like a choice? Or
No. If you do this way, if you do this way, you have to go down a half, up a half.
And that's with the histogram?
Yep.
I have to do that no matter what?
If you do it this way. If you do it the inequality method, you don't have to do that shit. So it's up to you. If I do the first class as 29 less than or equal to x less than 36.
And then the next class would be 36 less than or equal to x less than 43. Can somebody tell me which class would I put 36 into? First or second?
Second.
Second. Because the first one is less than 36, not equal to 36. Right? So now my numbers could look like this: 29, 36, 43, because there's no gaps. If you do it this way, there's inherently a gap there. Why did we have to make that 35? Because if I make it 36, where does 36 go? First and second? Do I double count them?
So the histogram has to go up by 0.5.
Yeah, so if you
If you create your distribution this way, these are the class limits. You have to use class boundaries when you graph. That's the trade-off. This looks a little better than these do. So the trade-off is your histogram is going to be a little bit harder to construct. There's a bit of a trade-off.
right? And I told you, you could do it this way, or you could do it this way. This way I can see the width this way and that way. It's nice. And my numbers could be whole numbers here, but it's up to you. You could use either way you want to. Is that better?
Yes, and then, so I know that we have a space to represent everything before 28.5. If I forget that, do I get points off?
Say it one more time, I'm sorry. You know that, the what now?
There's that space
Yes.
where it starts?
Yes.
0?
Yes.
If I forget that, do I get points off?
It depends. Probably not. In fact, some of you guys saw me do something like you had one class here and I did a little arrow like that. Yeah, it shouldn't be butted up to the thing. It should be a little space. In fact, technically, there's a little heartbeat symbol. A little heartbeat symbol that would indicate a break. But it's so often that we start where the data starts that I don't really use that symbol. But the little heartbeat symbol would mean there's a break from 0 to this. Yeah. So there should be a space there, just showing you that you're starting somewhere further down the line. Yeah. Yes.
So I recall you saying histograms, it's not like a bar graph where there's intentional spaces. There should only be an empty space in a histogram where there is an empty class. Is that, because of that, I guess that's only really defined like the middle of the histogram.
middle?
Like in between.
Oh, yeah. Once the data starts, if I see a break, if I see a gap, that means that there's no data in that gap. Yeah.
Okay, that's
Which is, again, a reason why we had to do the half thing here. Because if I graph them the way they are, there would be a gap between 35 and 36.
right.
Yeah.
Okay.
Yeah.
Why do we round it up and pass it? Does it just make it easier, or is there like?
Yeah, it really is. It just makes it easier. I mean, I could have made you guys, would you want to add 6.8? I'd rather not. Yeah.
Okay, so if it was like 6.1,
Then you can round up to 7.
okay.
Yeah.
Doesn't matter.
Yeah. Yeah.
Can you explain, question number 5?
So we talked about several, right? We talked about income, you would use the median. Why would you use the median instead of the mean? Yeah.
Extreme outliers would skew the mean.
Yeah, so the first example I gave was there are 4 people working at this place, 3 employees and the CEO, and the 38,000 a year, 40,000 a year, 42,000 a year, 650,000 a year. If I tell somebody the average, if I'm starting to work, I'm like, how much can I expect? And you give me the average, is that honest? No. If you give me the median, that's honest. In terms of about what kind of range of salary should I expect. You give me the median number, that is honest. So any data that has outliers, the median could very well be a more honest depiction of the center than the mean would be. Because the median doesn't give a shit what the numbers are. You guys with me? So like, if I had this data, 1, 2, 3, what's the median? 2, right? What if it's 1, 2, 3 billion? What's the median? 2, right? It's the number in the middle. Does the median give a shit what any of the numbers are? No, it just says what's the number in the middle. What's the mean going to be for this? Is the mean 1, 2, 3 and 1, 2, 3 billion? Is the mean going to be different? Will the mean be different between 1, 2, and 3, 1, 2, and 3 billion?
Yes.
Hell yes. It'll be much closer to 3 billion, yes? So that's not good. Or it'll be very vastly affected by 3 billion. It's going to be much higher than it would be otherwise.
Is there a symbol for median?
Yes, what's the symbol for the median? The mean is X bar. If the mean goes out, has a few drinks, falls over a few times, comes home, little thing got crooked, right? So that's the median, yeah. Okay. If you forget that, just write median. It's okay. Yeah.
So for 6B, standard deviation cannot be negative because it's only describing distance, not.
Oh, okay, I like that too. So I did a more mathematical approach.
Okay.
But I like the idea because I always do my joke about if you have negative distance, does that mean somebody's inside of you? If you're negative 4 feet away, Quaid, you know.
Right.
If anybody gets that
Even
reference.
if like all your data, you have like an extreme skew to the left or something, your standard deviation, and for whatever reason, your mean is not to the left or not. I guess it doesn't matter because it can't be negative.
Yeah, standard deviation can't be negative. The
Okay.
smallest standard deviation be is what?
Zero.
0. If all the data points are the same, then obviously the spread is 0. So real quick, before I forget, in section 2.6, there were a few things about, this is a symmetric, well, pretend like this is symmetric, right? Symmetric means it's a mirror image. If I think of this as a bunch of taffy, which side did I pull on to construct this picture? So this is skewed right. And of course, this would be skewed left. Later this semester, we're going to see a distribution that's skewed right like this. And I call it the Jabba the Hutt distribution because it looks like Jabba the Hutt. But that'll be later this semester. We'll see a distribution. It's not called Jabba the Hutt distribution. It's called the chi-square distribution, but that's later. Okay. So in section 2.6, they do talk about skewness. So really, literally, it's just which way did somebody pull? Skewed right, skewed left. Maybe. Okay. Yes?
So the test length is the same length as the practice test?
Roughly. I'm obviously going to have to cut back on the number of questions that would come from this page. so I can make room for the questions for the probability. I'm gonna construct the test to take, normally I construct the test to take an hour and a half for a 2-hour class. So then it gives another extra half an hour for people to kind of like double check and whatever. So yours is gonna construct it to take about 2 hours. We're not gonna start right at the start. We're gonna have the first 20 minutes or so for questions or whatever, and then we're gonna start whatever time we start, and then give you 2 hours, 2.5 hours from the time to finish it.
Equation sheet. That's-
Yeah, you're gonna bring your formula sheet with you. You're gonna bring extra paper if you need scratch paper. Coolness. And if you forgot your formula sheet and you come in late and you're like, oh, just tell me. Just say I forgot my formula sheet. I'll make one for you. It's incredible. I can be nice. I'm trying it out. So far I don't like it too much, but I'm still trying it out. Huh?
You're doing a good job.
It feels weird. It goes against my training. As a math teacher, I must take evil class, and I made an A++.
For quiz one of the questions had the sampling methods, and it said all patients from 4 randomly selected hospitals.
Yeah.
I was thinking of like all the hospitals in the whole like US.
Okay.
So would it be clusters since they're just picking 4 instead of like?
Yeah. All from some cluster. Some from all stratified. Yeah. Sounds very, Three Musketeers-ish, but all for some for all. Not quite, but it's close. It's the N Musketeers, make it a little more mathematical. See you tomorrow. So you guys, don't feel bad if you're ready. You can head out. It's fine. I'm not going to take your name down or whatever. If you have more questions, ask away.
So.
Oh, you need. You can redo this. That's you, right? Okay. Sure. Yeah. Let's do tomorrow. You got time?
Okay, thank you so much.
Sure.
So for that question, I wrote cluster because all the hospitals have a chance to get picked, but only 4 aren't. But I got these 2, so I'm not sure if I should.
Because you didn't quite. It's cluster because they broke it up into groups, and they took all from some of those groups.
Okay, so I just.
Yeah, you didn't really quite get it why it was cluster.
Okay.
Yeah.
I got you.
Yeah.
When are the quiz corrections due? Is it today?
Tomorrow. And again, you can turn in quiz 1 corrections on the day of the final. If you get enough corrections right, you might get some points, maybe 1 point or another. Right? So late things you could still get some points for. Right? Especially if you turn in homework like the next day after the test. I might not take anything off for that, but when I say that, understand you should do as much homework as you can to get ready for the test. Don't come to the test with entire sections of homework not done. Dear God, get in there and do a few, right? It's all about practicing. I always have somebody who's like, I couldn't do the last 4 because they didn't do anything from that. Why the hell? No, stop doing every problem I assign and just start doing every other one or something. Just get through, give yourself practice, and then finish it later. You are getting ready for the test because the tests are the most heaviest weighted things. You want to be ready for those. Okay. So yeah, if you want as many points back as you could get, they're due tomorrow. Yeah.
Do you have a stapler?
Yes. Where is it? Okay.
Sorry.
Also, you gave me this one back, but there was no marking on it, so.
Oh, weird. Let's see if I put it in the spreadsheet here. No, I didn't. All right, so I still need to grade that. I'm not sure. I must have gotten
And when you put correct on the homework, does that mean?
correct mistakes. You currently have half credit.
Okay.
Yeah. If I say okay or check mark, that means you got full credit, even if you missed a few. Yeah.
Okay. Is it okay if I get my first quiz back? I didn't get it
Oh,
yesterday.
yeah. Alina?
Yeah.
And here's some homework. So you can make corrections on this, so don't change the original on the back or another
And then
sheet of
this
paper,
one too,
just
right?
redo, huh?
And then
And then this one, same thing, you can make corrections.
Thanks. I even like, I wasn't know if there was any handouts that I missed.
Just the answer keys, yeah, no, when we finished the probability handout from yesterday, there wasn't any new handouts besides those answer keys.
And then the
Did you get your
quiz.
quiz?
I didn't do the first quiz, but the second quiz I did do, but I'm working on it.
Let's see if I can pick you out of here. No, what's your name?
Wait.
Oh, there you go. So you make corrections on that. Anybody else not get their quiz back?
I was wondering this too.
Oh, here we go. That's right.
Thank you.
Sure.
Do you need a separate group of homework and the corrections for the quiz?
No, just one big pile of stuff to do. Thank you.
Awesome, thank you.
Sure. All right, guys, so if you have questions still, feel free to ask. If you borrowed a calculator, don't forget your stuff if you're about to head out. I do have somebody section 1-4 homework that didn't put a name on it, so it's right there. That's not right.
Sir, do I just get like another piece of paper, just like write the corrections on here?
Yes.
Okay.
Thank you.
This is most common corrections, I'm not just sure about, yeah.
Ratio, because if we divide, it makes sources.
I have five minutes though.
So one, so
The school board finally.
it means up to, that's right, yeah.
Contacted me, they were coming today, I'm like, okay.
Or no, because data is put, no, data needs to be
Recreation.
in order to make sense.
So you want to play
No, this order could be alphabetical, no. Alphabetical never pass. There must be an order and reason for it to make sense. So if I put,
You gotta
you know,
be
so,
really proactive if you don't want
if I put rate my performance, 3 stars, 1 star, 5 stars, 4 stars, I'm like, why didn't you put those in order? You know, there's an order it wants to be in. So,
Needs to be ordered.
there's an order it wants to be in, yeah, not just that it is in order, but there's an order it must be in, yeah.
Says, what is the sample space?
Oh, yeah, shoot. Well, sample space is just a collection of everything that could happen.
Okay,
So notice, so what's one thing, if you pick one book, can you describe
Okay, so
what that would be?
like, so there's 12 different books.
Sure.
So,
And the numbers 1 to 8, very great titles. My favorite was number 6. So what's, if I pick a book, can you describe, what could it be?
it could be like 1, 2, 3, 4, 5,
Sure,
6, 7.
so pick one. Well, so it could be F,
It could be
8 or fiction, so it could be F8,
F8.
right?
Okay.
So now list everything, F1, F2, F3. blah, blah, blah.
Okay, and then I can do, and then like.
That's the
F1.
sample. Sample space is a collection of everything that could happen.
Okay,
Yeah,
cool.
cool.
Thank you.
You're welcome.
When are all the corrections due, including the quiz and homework?
Homework corrections, day of the final. Quiz and test corrections, day of the next test, so tomorrow.
Tomorrow,
Yeah.
okay.
See you. I got my stalwart people left. You guys are all working something.
This one's the one that's, I'm gonna have to say the most, actually.
Gotcha.
Go ahead, Ian.
What's up? I was gonna say, when we do the test correction, the judge just like write number one on there.
Anything you lost points on, redo.
And this is saying the ones that I lost points on, do I just write the number and then I write?
Yeah, write the number and then just do it right. Yeah. I like that. Just do it right.
Alright.
I'm so sorry.
Yeah, no, don't apologize.
So because data needs to be in order to make sense.
Yeah, this data needs to be in order to make sense, yes. Yeah.
So yeah, I just wanted to turn this in.
Cool, thank you.
Oh, Professor.
Yeah.
So when it's asking for probability, do you want us to convert it into a percentage always, or can we leave it as a decimal, or either?
For what?
For like one of the questions asking how many people owns a Ford or is female, once I get the
Oh.
number.
I'm gonna need a 4 decimal place answer.
Okay.
You can change it in percentage if you want to.
Okay, okay, thank you.
Homework corrections are due the day of the final. You can give it to me whenever you get them done. Quiz and test corrections, to get the most points back, it's due on the day of the test. So the first 2 quizzes, if you wanna make corrections, turn them in by tomorrow to get the most points back you can get. So you can make corrections, you can redo questions that you lost points on,
On the
right?
quiz.
What's happening? What's up? So if I give, are you good? If I give you a quiz back and you made mistakes, you can redo the ones you lost points on and you can get some points back. Yeah. Yeah.
So just make triple checking. Homework corrections, do the day of the final. Quiz corrections, you can technically turn them anytime, but for the most points you want to.
Due by the day of the next test.
Correct.
Yeah. Test and quiz corrections due by the day of the next test.
Oh,
So like by the day of test 2, test 1, and the quizzes will be due.
oh, okay, so we don't have to do all of our quiz 1 corrections by tomorrow.
You do. So again, quiz and test corrections due by the day of the next test.
Right,
So quiz 2, the next test is tomorrow, their corrections due tomorrow. Quiz 3,
okay,
they'll be due by the day of test 2.
so.
Test 1 corrections due by the day of test 2.
Fine. Great, thank you.
So if you,
So the width always has to be rounded up.
Doesn't always have to be, so it would have been cool, the mistake, if you make it a decimal, what sucks is, if you do it this way, this doesn't quite make sense. If you do it this way, it just, if these are decimals, this going up and down would actually have to go up by 0.05 and down by 0.05. And that just sucks, and that's why you don't have to make it a whole number, but if you don't, there's all kinds of things that happens. Yeah.
And then, in the 2-6 homework, 93, okay, so,
Oh yeah, this is
I
good.
don't know, they were just like worded funky, and it was.
The
I don't
median
know if I
age
missed
was
it.
30 and the median age is 34. What does it mean for the median age to rise?
So I said more people are living longer.
That's one thing. And really, what, and part B is give 2 reasons. One reason is more people are living longer. There's another thing that could happen. So there's either more people at the upper end, right, at the older ages, or there are less people at the lower end. So if we stop having babies, won't the median age go up over time?
Damn.
If we have more babies, won't the median age go down? So it's either people are living longer, or fewer babies are being born. Or it could be a combination of both.
Either way,
So, but how should part A be answered then? Because
Oh,
it's
part A is
all-
like a purely mathematical thing, so it would just mean that, the point that defines what half or above or below is going up. It's like a
Yeah, I
mathematical,
would,
it's kind of dumb.
This is very tricky.
But if you answer it sort of like when you do with part B, I
But I
understand.
said to you, I would
Yeah,
love
this
like-
question is not really well
So I
constructed.
would like.
Part B is the
You'll- you'll like-
physical reason, and part A is more of the math question.
You can honestly, I live off University.
Oh,
yeah, you're right there.
Yeah.
Number of children.
Yeah.
Oh, I see. See, that was the other thing. If the number of children are less, that's another reason the median age could go up. Yeah. So like you said, why doesn't it have to be that? Because you could have people living longer.
Yeah.
Cool. Whoa.